Good evening, Professor D here. This is a video on how to perform Benford's digital analysis. This is the tutorial data set that you can find in Canvas Module 3. And what I'll do with this data set mirrors what you will need to do with the data set for data exercise 1 in Module 3. So here we go. Got an Excel file here. This is the README first, important information. So you should read the information in this tab. All the red colored tabs, as you see down here, no work is to be done there. It's automated. Your work will be in the green colored tab called Working. So let's take a look at some of the tabs here. The Data tab shows the data. In this case, it's a short data set of a little over 1,000 cash disbursements with the payee and the check number. Now, Benford's digital analysis only works on what are referred to as naturally recurring numbers, like checks. What do we mean by naturally recurring? It means the first check here is not going to influence what the second check is. Unlike check numbers, which are predetermined. So when we have 4001, the next check is 4002. It can't be any other number. Now, the reason I have this data label in red, that's to preserve the data in case when you're working on this data set and you mess it up, you have preserved the original data set and you've copied over. So for Benford's digital analysis and exercise that you'll be doing in this tutorial, we're going to do, there's many different types of digital analysis. We're going to just do two of the tests. One is the first digit, which is the leftmost digit. And the second test will be the two leftmost digits. We'll get back to that in a minute. Here's a data profile where we just kind of took some different swipes at the data. I created different things I wanted to look at. You could change this and do it decide on different levels of detail. In this case, I've got different amounts that I want to look at and what is the count in there, what's the percentage total, what's the dollar amount, dollar total, etc. You could change that if you had another data set. Here's the first digit table. It has the information in from Benford's expectations, which you can read more about that in the write-up for the tutorial, where I explain how Benford came up with those expectations. Anyway, that's there. You'll see the actual information is empty because we haven't made the calculations yet. Here's the chart, which only has this line right now for Benford's expectations. This is second digit, same story. The actual information is not in there yet, and same with the chart. Okay, now I'm going to go back to working, and let's do a little bit of formulas to pick up the actual information based on this data set. So I'm going to start with the first digit and say equals left. Go to cell A2, that's the first cell. I times that by 1,000. And enter 1 for the first leftmost digit. Let's see if we get the right number. There it is, 2. Woohoo! Okay. Copy that down, copy that down, copy that down. Come on now. There we go. Okay, I'm going to do pretty much it's very similar. Startup equals left. A2 times 1,000. And select 2 to get the two leftmost digits. And we'll get 22. Perfect. Copy that down. Now let's see what we have. First digit table. We have the actual count. Got the difference between actual count and expected by Benford, actual percentage, Benford's expectation, difference in percent, and the Z statistics. The higher the number, the more significant the difference is. That's and here's the chart. The bars here are the actual, the line is the expected for Benford. And we see some deviation on one, a little higher, two lower, etc. The first and second digits, see the table's complete with the actual, the difference, actual percent difference, and again, the statistics. Again, the higher the Z score, the more significant the differences between the actual and expected. And here's the chart. Whoa, look at that. All kinds of stuff going on there. Now, what you would do is look at either big differences, like we see here and here, where the actual is over the expected, or big differences being under. Sometimes those differences have to do with, in this case, with cash dispersions, could have things to do with authorization, additional authorization required for amounts over a certain cash dispersion amount. So, for instance, perhaps two people have to sign off on the check for amounts over, let's say, $5,000. Maybe competitive bids are required for amounts over $10,000. So what you would do is if someone's trying to avoid having to go through those additional procedures, they might split disbursements into smaller amounts. So, for instance, instead of having a $20,000 disbursement, or purchase, which would require competitive bidding, maybe splitting that into a series of $5,000. So anyway, it's very useful and quick way to analyze the data and look for unusual anomalies that need further investigation. This doesn't mean that there's fraud or anything wrong. It just points us in the direction of looking at where to look. Thanks a bunch. Bye.